Hello and welcome to my YouTube channel ChemWis. In this video we are going to learn mass spectrometry of alcohols. We will learn how this technique provides unique insight into their molecular weight, fragmentation pattern and structures. We will first go through basic fragmentation rules for alcohols. For that, let's have a hypothetical secondary alcohol in which RS is a smaller group while RL is larger. In alcohol, the most loosely bound electrons are lone pair of electrons. Electronic bombardment removes one of those electrons and thus lead to the formation of radical cation called molecular cation. The first rule is regarding intensity of molecular ion. The rule 1 states that molecular ion peak for primary and secondary alcohols is very small, and for tertiary it is usually undetectable. Rule number 2 is regarding fragmentation of molecular ion. CC or CH bond next to oxygen generally breaks to generate fragment ion. The most prominent fragmentation is the one which expels the largest radical. Thus, in this molecular ion, removal of H radical will give protonated ketone that will correspond to M-1 peak. Removal of a smaller R group as radical will give protonated aldehyde with larger R group, while removal of larger R group as radical will give protonated aldehyde with a smaller R group. So, according to second rule, the protonated aldehyde with a smaller R group will be the most prominent peak as it is formed by the removal of largest R group, and formation of protonated ketone corresponding to M-1 peak will be the least favored. According to the third rule, alcohols with delta hydrogen show M-18 peak due to loss of water. M-18 minus alkene due to loss of water and alkene, and M-18 minus alkyl due to loss of water and alkyl group. M-18 peak is noticeable in primary alcohols and very weak in secondary and tertiary. For better understanding, let's have alcohol with delta hydrogen. Elimination of one non-bonding electron gives molecular ion. Delta hydrogen abstraction gives another radical cation. Elimination of water molecule gives radical carbocation that correspond to M-18 fragment. Elimination of alkene from this radical cation gives new radical cation that correspond to M-18 minus alkene. M-18 radical carbocation can eliminate alkyl radical like this to produce cyclobutyl carbocation that corresponds to M-18 minus alkyl fragment. Now let's go through examples. Mass spectrum of 1-propanol. The molecular weight of 1-propanol is 60. Electronic bombardment causes removal of one non-bonding electron to produce molecular ion with M/Z value of 60. Since this is a primary alcohol, so we can see that there is significant intensity of molecular ion peak. It can remove H radical to produce protonated propionaldehyde corresponding to M-1 peak having M/Z value of 59. Removal of ethyl radical from the molecular cation will give protonated formaldehyde that correspond to M by Z value of 31. The intensity of this peak is the highest because its formation involves removal of larger group as radical. Mass spectrum of 2-propanol. 2-propanol has the molecular weight 60. Upon electronic bombardment, there is elimination of one non-bonding electron to produce molecular ion with M by Z value of 60. Since it is a secondary alcohol, so the molecular ion peak is almost undetectable. The molecular ion removes H radical to produce M-1 peak having M by Z value of 59. Elimination of methyl radical from molecular cation gives protonated aldehyde with M by Z 45, which is the base peak of the spectrum. Mass spectrum of 1-pentanol. It has molecular weight 88. Removal of one non-bonding electron gives molecular ion with M by Z 88, which is non-detectable. Removal of H radical from molecular cation gives protonated pentanol that correspond to M-1 fragment with M by Z value of 87. This peak is also very small. Molecular ion removes butyl radical to produce protonated formaldehyde with M by Z value 31. Since 1-pentanol has delta hydrogen, so there will be abstraction of delta hydrogen. Let's draw the molecular ion in a conformation required for the abstraction of delta hydrogen. Abstraction of this delta hydrogen like this gives another radical cation with M by Z value of M by Z value equal to the molecular cation. Dehydration gives radical cation with M by Z value 70, which corresponds to M-18 peak. This radical cation removes methyl radical to produce cyclobutyl carbocation with M by Z value of 55 that correspond to M-18 minus radical peak. The same radical cation eliminates ethylene like this to produce propylene radical cation with M by Z value of 42 that corresponds to M-18 minus alkene peak. Mass spectrum of cyclohexanol. The molecular weight of cyclohexanol is 100. After electronic bombardment, it ejects one non-bonding electron to produce molecular ion with M by Z 100, which eliminates H radical like this to produce protonated cyclohexanone with M by Z value of 99. The molecular ion can undergo breaking of alpha beta CC bond to produce this radical cation, which undergoes hydrogen shift like this to produce another radical cation, which removes propyl radical like this to produce protonated acrolein with M by Z 57. The molecular cation undergoes delta proton abstraction to produce this radical cation, which eliminates water molecule to produce radical cation with M by Z value of 82. Mass spectrum of benzyl alcohol. Benzyl alcohol has molecular weight of 108. Elimination of one non-bonding electron gives molecular ion with M by Z value of 108. Removal of hydrogen radical from molecular cation gives protonated benzaldehyde, which rearranges to hydroxytropylium ion with M by Z value of 107. Removal of carbon monoxide from hydroxytropylium ion gives carbocation with M by Z value of 79, which then removes hydrogen gas to produce phenyl carbocation with M by Z value of 77. That's all in this video. Please subscribe my channel and press the bell icon if you like this video. Thank you very much for watching this video.